Hi everyone, welcome back. In fact, welcome back to the last day of Unit 1 of Grade 10 Math. Congratulations for making it here. So basically, today we're going to be talking about how to find the midpoint and also the length of a line segment when we are just given 2 points, two XY points. Let's first discuss the midpoint. So what do we do to find the x-coordinate of the midpoint? We just take the two x values and we divide them by 2. Or in other words, we find the average of those two values, and that's going to be our our middle point for x. Because if we think about it, let's say one of our points has an x value of 3 and the other has an x value of 5. Well, to get to the middle, we need whatever point has the x value of 4. We need to go right in the middle to get that midpoint. And same goes for y. We need to take the two y values and we need to divide them by 2 to get the new y coordinate that's going to give us our midpoint. And if we put those things together, we get the midpoint for our 2 points, the midpoint of the 2 points that we're looking at. Um, Now, what is a midpoint just kind of in general? Well, the midpoint is the point that, evenly divides a line, right? And so, what is the point where if we put a point between those two points, it would be equidistant from both lines, and not just equally distant, but, the shortest equal distance, right? Because if I draw this line, for example, you could say, oh, well, this point is equally distant, but so is this point. This is equal distance to this, right? You could argue that. And that may be true, but this point is also the shortest distance. It has to be the point right in the middle of those 2 points with that shortest distance there. The midpoint to where if we connected those 2 points, where would be the middle? And that would be the middle. So that's what we mean by midpoint is the line that actually not only evenly divides it into two separate parts, but that's the shortest way of doing that. Then we have length, and you might be thinking, well, this looks oddly like Pythagoras' theorem, and that's because it is. This is just a separate version of Pythagoras' theorem. And by the way, there's a lot more Pythagoras' theorem when this came from. Pythagoras' theorem comes up in its various ways a lot throughout math. Even at university level, variations of it are still popping up, and there will be more variations that even pop up in this course in grade 10 as well with cosine law and that sort of thing, which is a future topic that I won't get into today. But anyway, this is a version of Pythagoras' theorem. Essentially what we're doing is we're saying what's the difference between our x values, and we're going to square it. So what's our distance with respect to x? We're going to take it and we're going to square it. What's our distance with respect to y? We're going to square it, and then we're going to take the square root to find the length, the distance, the shortest distance between those 2 points. I'm actually going to show this graphically as well, as I think that will be useful. So let's show it graphically here. Let's actually go here and draw some nice straight lines. There we go. Okay. So if we were to find, let's say this is point 1, 2, 3, 4, 5 and 3, for example, right? And I have 2 points. I have the point that's here and the point that is, let's make this easy on ourselves, here, right? And I want to know, what is the length between these 2 points, right? What's the length of this? You might say, oh, I know, or you might say, I have no idea. I don't know what you're talking about. I don't know what you're getting at here. Well, but let's think of it this way, if you're not sure what I'm getting at. Well, essentially, this line is made up of what? It's made up of the x coordinates, right? The difference between the x values, which the x values are 1, 1, and 5, right? Right? So the x values are 1 and 5, so that difference, which is 4, right? And then there's the difference with respect to y with 3 and 0. So it's this difference right there. And so essentially it's like, okay, well, what is this? This is Pythagoras' theorem, right? This is saying this is the same thing as a right angled triangle, right? Essentially, we're going from one point to the other. And when we're going from one point to the other, we can just use our Pythagoras' theorem in this form of a triangle that I'm showing you here. So we can grab a 3 from here and a 4 from here. And then this is just our 3, 4, 5 triangle, right? We square those numbers, we take the square root, and we get 5 here, right? This is a very classic 3, 4, 5 triangle, as it turns out. Now, not all of them are going to end that nicely, but you can see from this simple example that we can expand this into other examples, that if we find the changes with respect to y and the change with respect to x, and we take those values and we square them and we add them up and then we square root them, we're doing Pythagoras' theorem in that sense, right? So the only new part here is really the taking the change in x and the change in y, but essentially that's just giving us the legs of our triangle. We're taking this line and we're saying this is the hypotenuse. If this is the hypotenuse of, a hypothetical triangle here, what are the legs of it? And if we can find out the legs of it, which we can from having those 2 points, we can find out the length between any 2 points on in 2 space on this type of graph. And we won't be going past 2 space in this course, so don't you worry. That's not till grade 12. Okay. All right, so very good. So I'm going to go ahead and give some examples. I'm going to ask, what is the midpoint? And shortest distance between, and let's do 2 examples. Let's say the first one is -2, 4, and 5, 10. And the second one, -8, -4, and 2, 3. So let's do that. Let's find the midpoint and the shortest distance for both. So the midpoint for this one, if we go back to our equation, it's going to be x1 plus x2 over 2. So -2 plus 5 over 2, comma 4 plus 10 over 2, which that's going to be equal to 3 over 2 and 14 over 2, which is equal to 1.5, comma 7. So there's our midpoint. Now, how about our distance? Our distance is going to be the change in x, right? It's going to be x1 or x2 minus x1, so 7 squared, plus 10 minus 4 squared, which is 6 squared, which is going to be root 49 plus 36, which let's see what that is. That's going to be root 85, which that is approximately 9.2. So that's about 9.2 units. And there we have it. All right, let's do one more example, and then I think that will be good for this day. Let's find the midpoint of these two. So the midpoint is x1 plus x2 over 2, y1 plus y2 over 2, which is going to be -8 plus 2 over 2, and then -4 plus 3 over 2, which is -6 over 2, and then -1 over 2, which is -3, comma a half. And there we go. And let's find the distance as well, or the length. That's going to be equal to x2 minus x1 squared plus y2 minus y1 squared, and then all of that square rooted. So x2 was what? x2 was 2, minus negative 8 will give us 10. So we got 10 squared here. And then y2 minus y1, let's see, 3 minus negative 4 is 7. So this is going to be equal to 149, the square root of 149. Now, 49 is a nice square, but I don't think that 149 is going to give us the same courtesy. So we'll approximate, and that's going to be about 12.2 units. And there we have it. All right, well, congratulations on finishing this day and also finishing the unit. We will see you guys for the next unit, but for now, take care and good work today. Bye, everyone.